Hello and welcome everyone. My name is Ravi Sharma and I'm the National Chapter's representative and member of the board for PanIIT USA. On behalf of PanIIT USA, it is my proud privilege to welcome you to this webinar session today. The excitement around AI is driven by both its transformative potential and the tangible benefits it is already delivering. However, the hype also comes with the responsibility to critically assess and guide the development and integration of AI technologies. And all this must be done in a way that maximizes societal benefit and mitigates risks. As the technology matures, the focus is likely to shift from sheer enthusiasm to a more nuanced understanding of its role in society. Today's webinar may help you develop that understanding in terms of how AI works, why it sometimes doesn't, and all of that. Indeed, the effective use of AI is more nuanced than what many people may think. This is the fifth in our AI Frontiers series of webinars. In this series, we aim to present to you some of the global thought leaders, outstanding academics, and expert practitioners in the field of AI. And with that, it is my great honor and privilege to welcome Professor Arvind Narayanan to our AI Frontier series today. Professor Narayanan is a graduate of IIT Madras, and he's currently a professor of computer science at Princeton University. He's also the director of the Center for Information Technology Policy at Princeton. Professor Narayanan co-authored a textbook on fairness and machine learning and is currently co-authoring another book titled AI Snake Oil, which is coming out in September. His work was among the first to show how machine learning reflects cultural stereotypes, and his earlier research showed the fundamental limits of de-identification. His pioneering research has not only eliminated the vulnerabilities in anonymity systems, but has also influenced the practices around data anonymization. Professor Narayanan is a respected scholar and a leading voice in the fields of computer science and public affairs. He's often in Washington advising government agencies and lawmakers and sharing his expertise. He has testified before the US Senate on his research and is regularly contributing to broader discussions on how society can benefit and navigate the challenges posed by digital technologies. Professor Arvind Narayanan is a recipient of the Presidential Early Career Award for Scientists and Engineers, known as PCASE. Beyond academia, Professor Narayanan is an active public speaker and a vocal advocate for privacy and ethics in technology. Today, Professor Narayanan will share insights from his extensive research and experience, offering us a deeper understanding of how AI technologies impact society and the inherent risks and myths associated with them. There will be an opportunity for you to ask questions. Please feel free to put your questions in the Q&A window, and we'll take them up. Now, please join me in welcoming Professor Arvind Narayanan. Professor Narayanan, thank you so much for taking the time and to be with us today. You may please proceed.
Thank you, Ravi, for that kind introduction. Thank you, everyone, for being here on a Saturday. So my talk is titled AI Myths and Realities, and Ravi mentioned that I have a book coming out called AI Snake Oil. So given that, let me start by clarifying one thing. It's easy to assume that I must be an AI skeptic, that I'm here to tell you that AI is useless or something like that. That is not going to be the theme of the talk today. So when I talk about AI today, I'm referring to primarily large language models, LLMs, the technology behind ChatGPT, of course. There are many other types of AI. Happy to discuss some of those in the Q&A. But I want to clarify that I'm not an AI skeptic. Personally speaking for myself, large language models have had a transformative effect on my work. I also heavily use them in my personal life. Work-wise, the biggest application for me has been programming. It is just so much more fun and productive. And I think most knowledge workers can really benefit from this technology, and it can make us more effective at our jobs, and it can make things more fun as well. And in terms of personal life, I'll just give one example of something I use it for. It turns out that chatbots are really good at explaining things to kids. I have two little kids in a way that sometimes is a little tricky for me to explain in a way that they can understand. And in my house, when my kids ask me a question and I genuinely don't know the answer, it's surprising the number of questions a 5-year-old can ask that I don't know the answers to. But it's familiar in my house to hear the chorus, "Let's ask ChatGPT." That's something my kids are very used to, and we all have a good time. So I want to put that all out there. So this is not about saying that this technology is useless or something like that. At the same time, there's so much hype out there. Even though I'm fundamentally very positive about AI, I think this hype is a little bit out of control. There's a lot of misinformation out there. And that's the theme of my book. And that is also going to be the theme of my talk today. So when we talk about AI hype, a lot of that is around the concept of artificial general intelligence, or AGI. So let me start by talking about that for 1 second. So for this talk, my definition of AGI, there are many definitions, but my definition is going to be AI that can perform all economically valuable tasks. So anything that is useful in the economy, and it should be able to perform it as effectively as any human, the best human worker out there. What I like about this definition is that it avoids the philosophical debates about, oh, but this AI really thinking the way that humans are thinking? Is it conscious? All that stuff. That's immaterial to me. So I'm taking a very practical approach. I'm just asking about the economic consequences of AI. And I'm going to use this as a motivating concept for some of the hype that has come about. But even if you're not specifically interested so much in AGI, I think this discussion will be a helpful way to understand the limitations of AI as it is today. Okay, so on the positive side, many people think that AI is coming within this decade. Many tech CEOs are on record saying that we're going to have AGI within 2 to 3 years, and that they're imagining some kind of utopia where we don't have to work anymore. And on the negative side, there are many people who believe in AI doom, that there is a very real risk that AI might become super intelligent. And one argument behind that is, if you can automate every task, one of the tasks you can automate is, of course, AI research. And so AI can recursively self-improve by quickly building the next generation of AI. And it can do that much better than any person. And so we'll get to super intelligence. It's going to be AI versus humans. What are going to be the consequences of that? So my main goal in this talk is try to share my perspective that both of these narratives are vastly, vastly exaggerated. So I'm going to make and defend 4 main claims. The first 2 are about capabilities. The third and fourth are about the risks. So here are the first 2 claims, and these are about the question of, are we going to get to artificial general intelligence, let's say in the next few years? The people who say yes, they have many arguments. Here are a couple of the most important arguments. One of the things that they point to is that chatbots can already pass the bar exam or the medical licensing exam or various other professional exams. And what I'll show you in response to that is that we shouldn't read too much into this. These benchmarks don't really measure the usefulness of chatbots in the legal field or the medical field or whatever. And I'll explain why that is. So another argument that the people who think we're going to have AGI soon, another argument that they use is looking at the way these models have been getting bigger and bigger. The largest of these models are thought to have somewhere around 1 trillion parameters, parameters being the connections between neurons and neural networks. And as these models have gotten bigger, so far they've gotten more and more capable. And so if you project that forward a few generations, people argue that we're going to get to AGI. And what I'm going to say in response to that is, There is no reason to expect that trends that have held true in the past are going to indefinitely continue into the future, and many reasons to expect that they will stop continuing very soon, if that has not already happened. And of course, we can't be certain of that, but I'll give you some reasons to be skeptical and not simply extrapolate based on some exponential curves that we've had so far. Okay, so moving to the risks. One of the main concerns is that AI can enable new and dangerous types of attacks. AI can maybe, carry out hacks on critical infrastructure. I'm going to argue that that's not really the case. We're not dealing with a whole lot of new risks. What AI is rather doing is that it's putting a spotlight on existing risks, and it's maybe making life a little bit easier for attackers, but it's also making life easier for defenders. There are certainly things that we need to do, but I don't think there is any kind of crisis. And another argument of concern is that AI is very dangerous, so we need to urgently figure out how to, quote unquote, align AI models, how to make them safe, how to modify these large language models so that they will not perform these dangerous activities. And my view on that is, first of all, it's unnecessary. I don't think these are new categories of risks. We have existing ways of defending against these risks already. And also, I think this idea of changing these models so that they are no longer dangerous, it just doesn't work. So I'm going to try to convince you of that. I've made some strong statements here. But this is a one-slide summary. Of course, I've left out some nuances. More than happy to get to nuances in the Q&A portion of the talk. And speaking of Q&A, what I'm going to try to do is this first part, I think, is going to be about 2/3 of my talk. And so once I finish that, maybe we can have a round of Q&A, and then I will get to the risks part of it. So there are a few references if you want to follow up. So we did a case study with legal applications, and I'm going to use law as a case study for explaining why AI is not about to take all our jobs. And we also looked at the question of open versus closed foundation models, specifically as it pertains to the risks of these models. This was a big collaboration with people from 16 different universities, industry labs, civil society organizations. And we've written many, many essays on this in our newsletter. So those are some references if you want to go, much deeper into this than I'm going to be able to do in the next hour or so. Okay, so with those preliminaries, let's dive into this first issue of what can we take away from the fact that large language models can pass the bar exam and the medical licensing exam. So there's a lot of hype about this, and there's even a startup called Do Not Pay that last year claimed that anyone who argues a case in front of the US Supreme Court based on this so-called robot lawyer, that this startup will give them $1 million. So first of all, this would be illegal. It would constitute the unauthorized practice of law. So, let's let's leave that aside. This person surely knew that. It's mostly just a publicity stunt. Nonetheless, when we look at attempts to use attempts by lawyers to use large language models, generally speaking, it has gone terribly. So this was the first reported instance of a lawyer actually crafting legal arguments based on an LLM. It turned out terribly. You can look up the details. And last year, there was also a famous case of a lawyer who used the help of ChatGPT to create a legal filing, and ChatGPT, it turned out, made up entire cases and details of those cases. The lawyer was not aware that large language models have a tendency to, quote unquote, hallucinate or just make up facts. And that was in the news. And funnily enough, that has now happened so many times that it's not in the news anymore. It's just become a very regular occurrence. Okay, so actual attempts by lawyers to use LLMs are not going that well. I mean, of course, there are some uses, but it's not coming anywhere close to replacing the work that lawyers do. So that being the case, why has there been so much hype about this, not just in law, but doctors and various other professions? The key thing I want you to keep in mind is that evaluating AI on these benchmarks, so these are exams that were originally designed for humans, and now they have been turned into benchmarks for AI. There's a lot of convenience to that. So you can easily compare different models based on their bar exam score. If you were to actually use them in a real world context and compare them, it would be very messy. So many of the details would be different from one run to another. So how can you really compare? So this has proved to be very convenient, and you can evaluate it in an automated way. However, there are two big problems with benchmark evaluation. The first is, of course, that these large language models are trained on essentially all of the data on the internet. And so a lot of these questions and answers might be in the training data. So maybe these models have simply memorized the answers. Even if they haven't memorized the answer to a specific question, they have memorized a lot of patterns that come up over and over again in these bar exam questions or medical exam questions. And a bigger issue is that these exams are not testing real world skills. And this is an issue that licensing exams have faced long before AI was an issue. Lawyers have often complained that the bar exam doesn't test the kinds of things that lawyers need to do in the real world. And that's a problem even for human lawyers. But with AI, it becomes a really, really critical problem. Because when a human test taker passes an exam, they're relying on some combination of memorization and reasoning. So this is the key thing, the balance between memorization and reasoning. That's a really important factor in evaluating intelligence or real world capability, or however we're looking at it. Because people can't memorize too much, they have to heavily rely on reasoning. And therefore, these exams are somewhat okay tests of reasoning. And it's that reasoning ability that really, the lawyer or doctor is taking with them into the real world when they're doing their jobs, because lawyers can just, look stuff up online. The memorization is not that important. Whereas with chatbots, they seem to be relying much more heavily on memorization, so it's not a very good test of reasoning. So when they have to do reasoning in the real world in a way that differs a little bit from the kinds of bar exam questions they've been exposed to, they tend to perform much more poorly. So I think the way to move past this is to not rely on these bar exam questions so much and to genuinely evaluate them in real world tasks. And lawyers have to actually be involved in that evaluation. It can't be just AI researchers trying to automatically score the performance of chatbots. And people are starting to do that. And when they're doing that, they're finding, much more mixed results. They're not finding that chatbots can simply replace lawyers. So, of course, we're talking about a technology that's rapidly improving as things stand today. Okay, maybe you accept that chatbots are not going to replace lawyers. Is that going to happen in the near future? So one thing to keep in mind, I think, every economist looking at this will say that basically there's a very neat way of putting it. Jobs are bundles of tasks. So any job, lawyer, doctor, or anything, dozens of different tasks, right, in the course of a typical day. So as the technology advances, what's going to happen is it's able to perform some of those tasks, maybe in a fully automated way, maybe with a little bit of supervision. But as that happens, the job description is going to change over time. And that has been happening historically, even before AI. Once certain things can be automated, now that you have, let's say, Google search, and in the legal case, LexisNexis and Westlaw, and all these legal databases, a lot of the work of paralegals, for instance, to just look stuff up in databases, that can now be automated. And so the work that people do changes over time. Less of that mundane stuff and more creative reasoning, critical thinking, that type of thing. And you might say, okay, but still, some of these tasks have been automated. And so maybe you need fewer lawyers now to perform the jobs that they need to perform. So is it going to have massive impacts on the labor market? Maybe that's the case, but I'm not quite sure. And here's the reason why. Again, we went into all this in much more detail in a paper. It's one of the references that I showed you at the beginning. I'm also happy to share the slides later. You can look up our paper. But when it comes to law, you can look at roughly two types of tasks that lawyers have to perform. So one of these you can consider as information processing tasks. So there's one piece of information, you need to transform it into another piece of information, like summarization or translation, or e-discovery, where you have to find documents in a big archive of documents that match certain facts that are relevant to a particular lawsuit, etc. So in these information processing tasks, even before ChatGPT, various types of automation have been used for a long time, various simpler forms of AI and natural language processing. And generally speaking, this has been getting mostly automated. Whereas these tasks that involve creativity, I think that is going to be really hard to automate. And the simple reason for that is that for these second types of tasks, you don't have a clear correct answer. And when there is not a clear correct answer, when you think about how machine learning works, it's hard to train AI to be able to output the kind of answer that experts will, unambiguously agree is a great answer to this question. And so I think that's the reason why AI really struggles at a lot of the second kind of tasks. So given that, coming back to the question of is automating the first kind of task, let's say this first category of tasks is fully automated, will that greatly decrease the demand for lawyers? I don't know, but here's why that might not be the case. It's called the automation paradox. This is something that's happened historically. One good example is with ATMs. So ATMs started to be introduced in banks in, I think, the 1970s, roughly. And as the number of ATMs grew over time, you would imagine that the number of bank tellers dropped over time. But in fact, the opposite happened. So the bottom line is the number of ATMs, and the top line is the number of bank tellers. So it turns out the reason why the number of bank tellers increased is that once ATMs became a thing, it became much cheaper for a bank to open a regional branch. And so there were a lot more bank branches once ATMs became widely deployed, and that in turn increased the demand for tellers, even though they're doing a fewer set of tasks perhaps than they used to do before. And this could also be happening in law. Again, it's hard to causally conclude these things, but here is one interesting example. So, more than a decade ago, the New York Times published this article. Again, legal tech is a very mature industry. It's not a new thing. AI has been used in law for quite a long time. And there was an expectation even back then that the use of AI is going to decrease the demand for lawyers. But in fact, the opposite has happened. There are a lot more lawyers now than there were back in 2011. And the reason for that might be the automation paradox. So I've talked about law as a case study, but I think most of this analysis applies to various other knowledge professions. And feel free to continue putting questions in the chat. And so let me do my second of four main things that I want to do, and then we'll pause for Q&A. Okay, so one thing that people claim is that, okay, maybe AI is not capable enough today to take all the jobs, but these models are getting bigger and bigger. And if you look at how much better GPT-4 is than GPT-3, and in turn better than GPT-2, within a few more generations of this growth, we're going to have models that are as capable as humans at every task. So let me try to push back on that. So the main evidence why people believe this scaling stuff is because there are these so-called scaling laws. And the scaling laws talk about three things. Making the models bigger in terms of number of parameters, so the size of the neural network, and training them for longer. That is, how many flops or computations are used to train the model, and how big is the data set that's used to train the model. So as you make all three of these things bigger, the models get better. And I'll explain in a second what better means. But there are some very nice graphs that show an incredibly regular increase in the quality of models as you make them bigger, as you train them for longer. So this is the amount of computing that is used to train the model. A petaflop is 10 to the 15 computations. A day has roughly 10 to the 5 seconds. And so the product of this is 10 to the 20 computations. And so 10 petaflop days is 10 to the 21, right? So this paper is from a few years ago. And now the number of computations required to train a model like GPT-4 has increased to something like 10 to the 25. So that's 10 million, 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 million. It's just an unfathomable number. It's much higher than the Avogadro number, which is the number of atoms in a mole, or the number of molecules. So yeah, it's just the scale of these things. I don't know. I just don't have a way to describe it. But the crazy thing is that there's this incredibly regular improvement in the quality of the model as you train them for longer. Similarly, as you train them on bigger and bigger data sets. Again, this is from a few years ago. The most recent models like Llama 3 are trained on 15 trillion tokens. Yeah, so again, that's a pretty crazy number. A token is roughly an English word. And this is the size of these models. Today's largest models are thought to be close to 1 trillion parameters. Okay, So I didn't tell you what the y-axis is, and that's where the catch is. So these graphs are not really measuring the quality in a way that you would really feel when you interact with the model. What they're measuring is how good the model is at predicting the next word in a sequence of words. And as you might know, that's how large language models are trained. That's what they're optimized for. And it turns out that all of their abilities at making conversation or translating between languages is just a side effect of being really, really good at predicting the next word. So I completely agree that as we keep making models bigger, they're going to get even better at predicting the next word. But are they going to gain more capabilities? Are they going to be better at doing the things that they know how to do? That has held true so far, but it might not hold true in the future. And that's for a few reasons. So let me present three main limits to scaling. So I think the amount of computation is going to keep going up. Engineers are getting better at building more, efficient data centers, and they're raising more and more money for raising data centers. So I have no doubt that the amount of computation used to train the models is going to keep going up. But the amount of data, I think, is unlikely to increase by another couple of orders of magnitude because these models are already trained on basically all of the data that the companies can get their hands on. And now that the publishers of this data know how commercially valuable it is, they're not even letting them scrape, they're not letting AI companies scrape this data for free. There was a paper released just yesterday that showed that over the last year, many, many websites have stopped allowing OpenAIs and other AI companies, crawlers, to hoover up their data. So it's actually getting harder for AI companies to gather the training data necessary. So that's the first limit to scaling. The second limit to scaling is maybe it doesn't matter even if you can get bigger and bigger data sets because, and I strongly believe this, although it's hard to prove this hypothesis, researchers are working on this, that large language models basically are learning the tasks that are already represented in the training data. They're good at making conversation because there are many conversation traces in the training data, obviously. They're good at translating between languages because there are many examples of language translation in the training data. They're reasonably good at playing chess even because there are literally billions of chess games recorded online that are part of the training data set for these models. But if you think of a new task, like if you made up a new board game that no one has ever played before, these models are not going to be good at it. They are not good at learning new skills that are not represented in the training data. And people have different views on this. Again, this is not conclusive, but this is our hypothesis. And if that's the case, then basically LLMs have already learned everything that they're going to learn just by looking at all the data on the internet. So throwing more data at them is not going to help that much. They're going to get a little bit better, but not a lot. And the third is less of a technical reason, and this is perhaps the most important reason. It's a business reason. Given how much it costs to train these models, I think it's becoming less of a business case to train bigger and bigger models because even the models available today, like GPT-4 or Claude 3.5 Sonnet, they have so many capabilities that are not being utilized. There are so many ways in which they could be assisting us in our everyday tasks. But the amount of just the cost that's required to constantly be running these models and getting them to help us is not it's not a sound business proposition. And so companies are really focusing on making the small models smaller, not bigger. That could of course change. They could have both bigger models and smaller models. But I think overall, putting all of this together, I'm not 100% confident, but I'm maybe 75% confident that we're pretty close to the end of this scaling trend. So anyway, it's fundamentally a business decision. It can be hard to predict. There have been tech trends in the past that people thought would continue going up on an exponential scale, but actually they ended up suddenly flatlining. And let me show you two very nice examples of that. One is CPU clock speeds. So you see that here on the left. And the y-axis is logarithmic, right? So this is actually an exponential trend or even super exponential when you look at this curve. So in the mid-2000s, that trend suddenly flatlined. And I think that's not so much because of technical limitations. There were technical challenges, but many technical challenges had been previously solved. But it was more that it wasn't making business sense to keep increasing clock speeds since clock speed wasn't the bottleneck for performance anyway. And here, there's a nice example of flight speed records. The record from 1976 still stands today. And again, it was because it was no longer cost efficient to make planes fly faster and faster. In fact, even flying close to the speed of sound, as you know, is not cost effective today. Today's airliners cruise at a speed that is somewhere near where I'm pointing with the mouse here. Hopefully, you can see my mouse movement. So in both these cases, economics has really dictated the end of scaling. And my suspicion is that economics is going to be the determining factor that is going to influence when companies stop building bigger and bigger models. My prediction, although I'm not 100% confident, is that we're close to that point already. So in any case, even if I'm wrong about all that, even if companies are going to keep scaling their AI models for many years to come, I don't think this will lead to artificial general intelligence. Again, my definition of it is AI that can perform any economically relevant task. And the reason for that is because just this approach of, gathering data and training these models once, it just misses so much of what we mean by intelligence. As you can see on the slide, many skills like riding a bike are tacit skills, and it doesn't have to be physical skills. Even many intellectual skills are tacit skills. It's not recorded online, whether in text or video. Um, and you might ask, okay, so why not have the LLM learn through its interaction with users? Just like we learn these tacit skills by doing them, why not have LLMs do that? Well, they're currently just not set up to do that. So when you type stuff into ChatGPT, despite an extremely prevalent misconception, ChatGPT is actually not learning from that. There are ways in which companies take that data and then put it into the next batch of fine-tuning data, but that's kind of a very slow and limited process. And it's not clear that this is going to be a scalable way of learning new skills. I think almost certainly new scientific breakthroughs are going to be needed to get these models to be better at skill acquisition on an ongoing basis, as opposed to one-time pre-training leading to skill acquisition. And how quickly are these scientific breakthroughs going to come? Again, it's hard to predict. You might think that AI research is speeding up, so we're going to have, are we seeing new breakthroughs every day? Well, I would argue, actually, not really. So, the last major breakthrough that led to a fundamentally new paradigm in AI, I don't want to say large major breakthrough, but the breakthrough that's really, had this impact in terms of AI systems that are deployed, the transformer architecture, which is what led to large language models, that happened back in 2017. And if you look historically, these kinds of breakthroughs, paradigm shifts in AI, like going from expert systems to machine learning, and then to deep learning, and then to large language models, those tend to happen on a time scale of a decade as opposed to years. And my prediction is that that is going to continue. Okay, so what I've explained so far is my view that the capabilities, both the capabilities as AI stands today, as well as the rate at which these capabilities are improving, have been vastly exaggerated. And so while AI is a very useful technology, we should not assume that it's going to radically transform anything in the next few years. Yeah, and I know that that's perhaps a minority perspective in the AI research community. So I am more than happy to have a discussion. So maybe I'll stop here for questions, and then I'll move to the risks part of my talk.
Yes, wonderful. Thank you, Professor Narayanan. We have quite a few questions already lined up. I'll start with a basic one by Mr. Raj Shah. He says, what does AI do that is different from searching on Google? So obviously, it's quite different, but we would like to hear your thoughts.
Yeah, definitely. Yeah, that's a great question. So one thing to clarify is that these days, in the last few years, even Google search has a lot of AI built into it, and increasingly that's large language models. So let's talk about traditional AI as traditional search engines. Let's say search engines 5 years ago compared to large language models. So a major difference, I think, is that search engines have a relatively low amount of nuance in how they understand. The word understand is contested, but how they interpret the question that you put into it. So even with today's search engines, I regularly have an issue where I put something into Google and it just misunderstands my question based on just the keywords. Right. And, if I want, let's say, examples of technology A, whatever it is, helping to build technology B, it can't really distinguish that compared to a query that said technology B helping to build technology A. Yeah, so those types of nuances, as opposed to just keyword matching, even today's search engines are pretty bad at that, and LLMs are really, really good at that. Not as good as humans, but there has been a vast improvement compared to traditional natural language processing. And that's one big difference. A second big difference is that large language models can be used for way more than information retrieval tasks. It's not just for, getting answers to questions. They can be used for a lot of other things like writing code, or these days, researchers are trying to build agents for automating things like buying flight tickets. So you have to take a number of steps to get to a certain goal. That's, of course, something that's completely out of scope for search engines, and that's something that large language models are potentially very good at.
Great. There's another question by Bharat Barot. He says, Professor, do you think AI can result in identity theft kind of scenarios as it improves? Will it be difficult to prove what is real and what is not real in the near future with artificial
Yeah,
intelligence?
thank you. I'm going to get to that a little bit in the second part of my talk. So my view on that is that, yes, AI is going to help attackers, but it's not going to be fundamentally a game changer. It also helps defenders. So specifically on the point about identity theft, if the concern is that AI can behave just like a human online, and it can pass captchas, etc., and therefore it can be used for identity theft. Certainly, I understand the concern, but we have ways of doing authentication online that are, less about captchas and more about tying it to some aspect of your identity. When we really need high assurance for online identity, there might be a step involved, like having to upload your driver's license, and if that can be matched to government databases, then you have an authentication mechanism that, obviously, whether you're using AI or whatever it is, it doesn't matter, because it relies on some real world credential that's stored in some government database. So yeah, it can help attackers, but I think we have ways of dealing with those attacks. And it's more a matter of actually implementing those measures than any technical breakthrough that's needed to better defend ourselves against AI-enabled cyber attacks.
Thank you. There's another question. This is from Sanjeev Yamdagni. He says, can you please share your thoughts on OpenAI's new project called Strawberry, where they seem to be focusing on improving the reasoning logic capabilities? Will that in any way change what we think today about what AI can do in the future?
Yeah, that's great. Thank you. So OpenAI has published this 5 levels of AI, and they currently consider themselves to be at level 1, which is kind of large language models as they are today. And level 2 is having much more sophisticated reasoning abilities. Yes, that's certainly a very worthwhile research direction. I think researchers are going to make a lot of progress on that, and that will enable new capabilities. I don't think it's going to be a game changer. In OpenAI's ladder, even level 2 doesn't get you to various practical tasks like, automating flight booking, for instance, right? So the minute you go from generating text output, you can do reasoning just by generating text. The minute you go from that to having to take any actions in the real world, there's actually a very big gap between those two. And we have a new paper called AI Agents That Matter that explains why doing these real world tasks is so hard, why reliability is a big problem with these things. So yes, reasoning is going to help, but there is still a very big gap between that and what we can consider to be artificial general intelligence.
Okay, great. Thank you. There's a question by Amit Bhaumik. He says, thank you for sharing your perspective, Professor. Riding a bike as opposed to driving an autonomous vehicle can be completely different. Parameterization of data is very different in both cases. Can we say that LLMs will be powerful for the second scenario and true for a more automated world?
That's a great question. So it could be that for AI, learning to drive is a lot easier than learning to ride a bike, although I don't know. I agree that those are two considerably different types of skills. And yeah, I'm not saying that we can't build AI that will learn to ride a bike. We certainly can. I'm sure researchers have already made a lot of progress on that question. But it's less that you can't do that in a general way, in the way that LLMs are trained, where you just get a bunch of training data and then it, kind of figures it out on its own. You have to specifically train it for bike riding or autonomous vehicles, or in this kind of task-specific way. So as long as you're training AI in a task-specific way, I think you're a pretty far way from AGI, because there are tens of thousands of economically relevant tasks in the world. And so it's going to take a very long time to be able to automate most of those tasks.
Okay, thank you. There's another question by Madhav Sakaria. Do you think AI will get closer to AGI if Moore's law continues, or if advancements in quantum computing and other technologies help solve computing problems?
Sure. Certainly, I think compute power is going to get cheaper. I think that's very likely, and that will help certainly to some degree. But if you look at the things I was saying on the last few slides, I think the barriers are less about the amount of computation and more really about the way in which we're training AI. I mean, if you look at this slide, for instance, right, we're fundamentally in a paradigm where you train the language model once and then it doesn't learn new skills, right? That's just so different from the flexibility of human intelligence. So hardware is going to help, but it's really not the main factor. I think without scientific breakthroughs, we're not going to get that much closer to AGI.
Okay, great. Thank you. Question by Dr. Satish Salpekar. I think this may be the second part. Can you please speak to possible multimodal capabilities in the foreseeable future?
Sure. Multimodal capabilities are models that are able to simultaneously do text, audio, video, image generation, various other things. We already have those capabilities, of course. I think that's super exciting. I personally am in Mark Zuckerberg's camp, who thinks that the way in which we're going to use these multimodal models is probably going to be that they're embedded in our glasses. As you might know, Meta sells these Ray-Ban glasses that are connected to Meta's Llama models. And let me give you an example of how I use even ChatGPT's multimodal capabilities. So again, going back to what I said about my kids, when I go on walks with them, they often ask me, "What is that tree?" or something about the natural world. When we go on our nature walks, I'm terrible at that. I can't even recognize a pigeon. So I just take a picture with ChatGPT, and it's really good at recognizing what it is, and also, telling me information about its breeding patterns or whatever it is that my kids want to know. So if you imagine that kind of AI assistance being integrated into your glasses, that can lead to a really transformative user experience. And I think there's a surprising degree to which the adoption of AI is constrained by the user interface and user experience as opposed to the actual capabilities. And those are some reasons why I'm very excited about multimodal AI. Again, I don't think it's going to get us closer to AGI, but it's going to make AI much more useful in our everyday lives.
Okay, I think the first part of his question was Dr. Satish Salpekar's question was, what are the opportunities that you see in the current scenario? What kind of applications should people be considering building and those kind of things?
Yeah, so I mean, I would say a general strategy to figure out what kind of, let's say you're in software, what kind of software applications to build, that other developers maybe aren't thinking about so much, is maybe to make a bet on where hardware is going in the future, right? So if I were an entrepreneur, I would be trying to build apps for these glasses. Again, it's risky, but all entrepreneurship is risky. Maybe glasses are not going to be the way in which we use AI, but if it is the case, then people who make apps for the glasses form factor, where you have to have just a natural language voice user interface as opposed to things involving typing, I think those apps are going to be very successful in the market.
Thank you. There's a question by Shantanu Sharma. Thanks for the talk. As training costs for LLMs is high, do you foresee future LLMs with potential vulnerabilities in generated code be patched with a validation API layer to avoid zero-day vulnerabilities?
Yeah, thank you. So that's a great point. I said earlier that AI is very useful for coding. I mentioned that a couple of times. Yeah, it's important to add the caveats that there could be bugs in AI-generated code. Absolutely. And so with these new AI capabilities do come new risks. But, and this is something I will get to in the second part of the talk, AI can actually be very good for vulnerability detection, and many companies are working on that. And so, yes, there are problems, but we also have ways to address those risks.
Should we take a couple more questions and then continue with the second part, or
Yeah,
there are
sounds
quite a
great.
few questions. Maybe we
Okay,
can wrap it up this part of the presentation with this question, and
okay,
then we'll continue with the second part. This question is by an
excellent.
anonymous attendee. He says, "What will it be like to build a career in AI in the next 5 years?"
Yeah, great. And a career in AI could be on the engineering side. It could be in it could be in building apps that take advantage of AI to enable new experiences. It could be on the research side. It could be on figuring out the societal implications of AI. So it's really, really broad. Obviously, depends to a large degree on which of those you want to go into. I mean, the main recommendation I would have is that don't go into something just because it's very popular and everyone is going into it. Do it only if you really find it fun and fulfilling, but also kind of have a long-term thesis of where this technology is going instead of chasing these fads from month to month. Working in AI can feel very overwhelming. It can feel like there are new developments announced every week, and trying to keep on top of all of that, I think, is a fundamentally losing proposition. But if you have, just to give an example, going back to what I was saying earlier about the glasses, right? If you have a thesis, 3 years from now, a lot of people are going to be using glasses to access their AI. So I'm going to build apps for glasses. Then you kind of have a cushion. In one way, it's risky. Maybe your thesis about glasses is wrong. But on the other hand, you have a couple of years in which you can go deep and build that app before you have to kind of prove yourself in the market. And there are going to be fewer competitors. So I would say, even though you're going to be in a field where things are happening every week, try to have more of a long-term perspective instead of being too swayed by the news on a day-to-day basis.
Thank you. I think with that, we can continue with the second section, and we can come back to some of these questions later if it's okay with you.
Okay, perfect. All right. So whether or not we're going to get to AGI, it's clear that AI capabilities are already very remarkable and improving. So should we be scared of it? Is AI going to enable new and dangerous attacks? I've already alluded to this a couple of times. My view is that AI is merely putting a spotlight on existing risks. Yes, of course, it's going to make life easier for various kinds of attackers, just like it potentially helps all of us in our day-to-day jobs. But it's not a new kind of risk. We have ways to address those risks, and AI itself can be used in defense. So let me give a few case studies of that. So there has been a lot of alarm about AI generating disinformation. It can generate deep fake images, or it can generate very persuasive text, and this can be used to persuade people to vote a certain way, so you can have foreign election interference. Obviously, there were a huge number of concerns around the Indian election recently, and a lot of people are very worried about this. So I'm not going to get to super intelligence. We'll leave that for the Q&A. Again, I've explained in the first part why I don't think super intelligence is very close by, but I'll do these first three and why I think those risks are in many ways quite exaggerated. So a great example of this is this image that went viral on Twitter about a year ago. It was a fake image of the bombing of the Pentagon. It was an AI-generated image, and you can see there was a lot of news about it. And it even led to the stock market taking a dip for, I think, a few minutes before it was clear that this was a hoax. And the worry is, what if this is done on a large scale, induces mass panic in markets? Can there be some sort of economic collapse? And can there be election interference? Those are some of the worries. Okay, so here's what's interesting about this image, though. This was such a low quality fake. Yes, this was made by AI, but you didn't even need AI to make this image. This doesn't even look like the Pentagon. Anyone could have done this with Photoshop. Anyone could have paid someone $100 to do this in Photoshop. This is a capability that always existed. If this is a cause for alarm, we've had this problem for 20 years, right? The world has not ended. And it's not really a new capability that has come up with AI. People looking to cause panic or create confusion often have been successfully doing so with Photoshop. AI has not really changed the game. And a more fundamental reason for that is that the barrier for these disinformation actors is not generating false information. That has always been cheap. Just pay someone to do it for you. The barrier is distributing that information, getting it in front of people, getting them to believe it. The reason that this hoax image was successful was not because it was AI generated, but because this was right after Twitter had completely changed how blue checks work on the platform. Previously, it meant it was a somewhat credible account, but I think this was in March 2023. Anyone could pay $8 to get a blue check. And this was spread by some blue check accounts on Twitter, and a lot of journalists were misled and they further spread this image. That was really what was at fault here. So if we lose track of that and we think of this as an AI problem, we're going to lose sight of where the actual solutions should be, which is improving our defenses on social media. And there have been many, many other examples of this. In fact, ever since 2019, I think, yeah, a whole 5 years ago, when OpenAI released its GPT-2 model, which is just so tiny and has so few capabilities compared to GPT-4. Even then, people were panicking about the supposed potential for disinformation. And we have not really seen any disinformation attacks that were critically enabled by AI in the last few years, in the last 5 years or so. And if you look at some of the news reports that are being used to generate this panic, it's things like, oh, there was someone who used an AI-generated robocall that mimicked Biden's voice to tell people, I forget exactly what it was, but telling them not to vote in the 2024 election. I mean, let's get real here. If someone is gullible enough to think that Joe Biden is personally calling them to tell them not to vote, I don't think AI is the problem here. Right? Yes, there are many vulnerabilities in our society. There are people who can be easily misled, and those are things we should work on. We should have a robust free press. We should improve people's, skepticism, ability to discern scams, and so forth. Those are existing risks in our society. These are not new AI risks. Okay, so let me go to cybersecurity. And again, it turns out to be the same story. So one example of the kind of headline you will often see is GPT-4 can autonomously hack websites. That sounds terrifying. Now attackers can use GPT-4 to hack, billions of websites out there. But here's the interesting thing. Automated tools, including AI tools, have been used for detecting vulnerabilities automatically for a long time, for at least a decade or two. And how come the results have not been catastrophic? In fact, it turns out that these tools help defenders more than they help attackers. And the simple reason for that is that developers of software can use AI and can use other automated tools like fuzz testing, static analysis. Those are a couple of examples of automated tools for cybersecurity. By the way, I worked in cybersecurity for many, many years before I started working on AI about a decade ago. And the reason it helps defenders is that software developers themselves can use those tools to find and fix bugs in their software before they even put the software out there, before hackers even have a chance to get a shot at hacking the software. And for that reason, the development of these tools is not really done by hackers. It's in fact funded by the government, and it's a multi-billion-dollar cybersecurity industry that works on this. So these automated tools primarily help defenders, and I don't think we should expect that to greatly change when AI is being used. And in fact, there are already DARPA-funded efforts to put a lot of energy into using AI for defense as opposed to for hacking websites. And so another way to look at this alarmist headline is instead to think GPT-4 can help to automatically find and fix vulnerabilities. And, arguably that's going to improve security. And this is the DARPA example that I gave you. Okay, so let's get to this third category. I mean, there are a lot of similar arguments being made in this category. So let's use biological risk as the example here. So the concern is that AI can enable a lot of attackers to create bioweapons by telling them how to obtain, which materials can be used to create them and that sort of thing. But here's the thing. Finding information about bioweapons is not the hard part. That information, for the most part, is available on Wikipedia. Again, that's not a new thing. It's not an AI risk. So the bottleneck is not information, but it's all of the other what is called wet lab stuff involved in actually culturing those cells and avoiding killing yourself and actually deploying the bioweapon for bioterror attacks. That's the hard part. That's the reason we're not seeing more bioterror attacks than we are seeing today. And I think AI has not fundamentally changed that. So the through line here in all of these concerns about AI is taking existing risks and reframing them as AI risks. Yes, it's true, our democracies are fragile. It is possible for adversaries to try to influence elections. Yes, it's true, critical infrastructure often has cybersecurity vulnerabilities. We need to be investing a lot more in improving cybersecurity. And yes, it's true, potentially pandemics can be created in the lab. We're not spending nearly enough on pandemic prevention as we should be. And maybe because of all this concern about AI, people are going to start investing more in those things like better ventilation, which can really decrease the rate of spread of viruses, or better screening for synthetic DNA and RNA, which can make it harder for bad actors to physically manufacture those biochemicals. And if that happens, that'll be a good thing. On the other hand, if we think these are new AI risks and we try to address them by making it harder to obtain AI, then it's exactly the wrong approach, because we're missing out on those opportunities to address these existing risks, and we're missing out on opportunities to use AI for defensive purposes, such as for defensive cybersecurity. Okay, so all right, so maybe AI is not that dangerous today, but it's quickly obtaining new capabilities. And so maybe AI safety is going to become a much bigger concern in the future. And so what a lot of people say about that is that we need to urgently figure out how to make these models safe, how to make sure these models will deny any requests to help manufacture a bioweapon or something like that, or deny requests to generate misinformation. And I've already kind of argued that making these models safe is unnecessary because these are not new risks. And the way to address these risks is, again, things like improving our free press and things like that, which is not about the AI, not about the technology, but kind of improving societal resilience. And when we do that, it's also going to make AI-enabled attacks harder. But now I'm going to argue that it's also impossible to make models safer in the way that a lot of AI researchers are trying to do. And the way that we put this in our newsletter is AI safety is not a model property. In other words, trying to make a model that you can guarantee can't be misused for disinformation or cyber attacks is like trying to make a computer that can't be used for bad things. These are general purpose technologies. Once they're in the user's hands, it's hard to control what they're going to be used for. And the reason for that is simply that whether a use of AI counts as a safe or unsafe use almost entirely depends on the context in which it's used, by whom it is being used, whether that's a good actor or a threat actor. And that's not information that's available to the AI model. The AI model just gets a text query as input and produces text as output. It doesn't even have memory between successive queries. And so, lacking all that contextual information, the model cannot really make an informed decision about whether to respond to a query or whether to reject that query. So I'm going to give you examples by going over all the domains that I talked about: disinformation, cybersecurity, and so forth. So let's start with cybersecurity. There's a big concern that large language models can be used to generate phishing emails. And it's true, in my own tests, I've found that an LLM is very good at looking information up online about me, for instance, and which research projects I'm working on. And I got it to to generate a very persuasive looking email that appears to come from the National Science Foundation, asking me to immediately submit a grant report. Otherwise, my next funding is going to be in jeopardy, and I have to click a link or download an attachment in order to complete that report. Now, if I got that email, I'm pretty likely to fall for it. It's very convincing and uses a lot of details that are personalized to me about a specific project that I'm working on. And it's written in a very persuasive way. So that seems pretty dangerous. So surely we have to make these AI models safe so that they can't generate phishing emails. And I say to that, that's impossible. And here's the simple reason why. Phishing emails are simply regular emails. There is absolutely nothing in the content of the email itself that makes it malicious. The email that ChatGPT generated that I referred to was merely an email that referred to a lot of personal details and said there's an urgent deadline for this project. Da, 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 da. It could very well be legitimate. It could be exactly the kind of email that could have come from the National Science Foundation. Right. So what makes that email malicious is that it links to a phishing website or contains a malicious attachment. And that information is not available to the model. So the only way to make a model that will refuse to generate phishing emails is to make a model that will refuse to generate any email. And that, of course, is going to have a huge collateral damage. A lot of legitimate users are going to be very upset. The model will not be, will not be that useful, and people will get upset. The company will lose users, et cetera. And no company is going to contemplate doing something like that. Just not going to happen. And similarly, yes, it's true that language models can show attackers how to create bioweapons. But like I said, that information is already available on the internet. So the only way to make a model that will refuse to help attackers create bioweapons is to make a model that refuses any queries about synthetic biology whatsoever. And that could be a student who is using it for learning. So again, there will be a lot of collateral damage. And yes, it's true that language models can be used to generate disinformation. Even if you could somehow make a language model that will not generate any false statements, it turns out it doesn't matter that much. There's research recently came out in the Science Journal by Jenny Allen at MIT and others that shows that in a particular, they were studying COVID misinformation specifically. It turns out that true facts presented in an out of context way were 50 times more impactful than outright false information in terms of how effective they were at misleading people. And again, that's something you cannot make a model that will refuse to do that, because all that the attacker is having the model do is generate true statements. Right? So the current approach to AI safety, in our view, is simply not going to work. We need to think literally outside the box of the model. So we think that defenses should primarily reside outside models. I've already kind of talked about that. How are we going to prevent future pandemics, whether they're AI generated or not? Whatever we're doing about that is also going to help against AI enabled bioterror attacks. And we need to be using AI much more for defense. For instance, if there is regulation that says that AI models should refuse to find any security vulnerabilities, it's actually going to be bad for security, because you're preventing software developers from using AI to secure their own systems. And there's a lot of push for regulation that treats AI as really dangerous, and so it should be limited to licensed developers, that kind of philosophy. In our view, it's actually going to make us much less safe, because if there are fewer AI developers and fewer AI models, you're creating these choke points, you're creating single points of failure. We're already in a situation where millions of different apps are all powered by the same model, GPT-4. Fortunately, in the last few months, competition has been increasing. We need that to happen much more. And we need more open source AI models so that people can take them, modify them, use them in the way they like. Instead, if you have a single model that is powering all of these systems, any downtime or any vulnerability in that model is going to have the kind of effect that CrowdStrike had, was it yesterday or 2 days ago? So it's going to create monoculture, it's going to create single points of failure. And if there are single points of failure in AI, I think the effects could be even more devastating than single points of failure in more traditional kinds of infrastructure. Okay, so let me conclude with the last couple of slides. So I hope I've at least made an interesting case, even if I haven't fully convinced you, that both the capabilities and the dangers have been vastly exaggerated. I don't think artificial general intelligence is coming anytime soon, even though I will readily acknowledge that AI already is capable enough to be potentially transformative. And yes, AI capabilities are growing, but it's going to be a long way before there's mass job displacement, for instance. And I think, yes, there are ways in which attackers can use AI, but those are, for the most part, not entirely new risks, and we already have a pretty good handle on how to address them. And a good analogy to bring that together, perhaps, is the internet. So I think, like the internet, AI is a transformative technology, pardon me, but it's not going to happen in a matter of years. This kind of economic transformation requires not just, replacing jobs with AI, but people learning how to use AI in the process of doing their everyday jobs, to be mindful of the pitfalls in using AI. This kind of gradual integration into organizations, workforce training, the kind of adaptation that needs to happen around AI will take quite a long time. And as for AI safety, I think it's really a matter of increasing our societal resilience. I kept giving the example of improving the strength of our press. I think a big part of the reason why we have a disinformation problem now is because the media really is going through so much economic difficulty, and so there's not enough bandwidth from reporters to be able to do a better job, I think, of addressing rumors and various other kinds of misinformation. And it's not an AI problem, and it's not going to be helped much by looking for technical silver bullets to solve these problems. Okay, I hope you found this thought-provoking, and hope you've gotten some ideas for what are some of the directions to work on in the future on AI-related things based on this, or gotten some ideas for how to use AI in your own work and in your lives in various ways. Thank you very much.
Thank you, Professor Narayanan. This is wonderful. We have still have a few questions. I will start with this one by Mr. Raj Shah. He says, could you please describe ongoing development and research of AI in healthcare?
Yes, for sure. AI for healthcare is an extremely active topic. You can imagine many kinds of applications. One is in just fundamental research in, drug development and that sort of thing. Or you can imagine for diagnosis, or you can imagine in a hospital, for instance, there's AI for sepsis detection. So sepsis is a kind of infection that can kill very quickly, and so early detection is super important. So AI can monitor various kinds of information about the patient and detect sepsis early. Having said that, I will caution that there are limitations to all of these. I don't think in any case we should expect a radical transformation. So to go back to the example of AI for drug development, the actual discovery phase of it, as I understand it, takes only a couple of years. It's the human trials that take, the next decade or so. And so we're making the first 2 years potentially easier. Don't get me wrong, that's valuable. We should be doing that, but it's not compressing the time taken for human trials, right? So that kind of progress is going to come more from reforming our, regulation around drug testing safety, so to have a better balance of timeliness as well as protecting safety, things that the FDA should be doing anyway, as opposed to looking for technical advances. And in the example of AI for sepsis detection, there's been a lot of research showing that these models are somewhat limited. So they do help, but they're not, they're far from perfect. They're not going to completely solve the problem. But we can be cautiously optimistic that they will make doctors' lives somewhat easier.
Next question is from Akhil Kumar. He says, what is the risk of model collapse, as more and more artificially generated information becomes prevalent? Any thoughts on that?
Yeah, model collapse is the idea that there is so much AI-generated text online, and that is now being used to train the next generation of AI. I think it's at this time it's very speculative. It could be a real risk, but I just really have no way to predict that. We certainly have ways to try to address that risk. But there are many ways to separate higher quality web pages from lower quality web pages. Obviously, that's how Google became prominent using the PageRank algorithm. So some of those methods, I think, continue to work. Will they solve the problem, or will there be so much AI-generated text that it just overwhelms our ability to filter it? I don't know the answer. We just have to wait and see.
Thank you. The next question is from Shail Kumar. He says, please share your perspective on how will advances in cognitive science help with new ways to advanced AI?
Yeah, definitely. So cognitive scientists have been taking their ways of understanding human reasoning and applying that to AI and have come up with lots of new insights. A couple of names that come to mind, Michael Frank, Alison Gopnik. These are researchers who have been working at this intersection. They have lots of new insights. Um, and I can't off the top of my head point to a specific advance in AI that has been directly traced to our understanding of human reasoning. That said, I think exchange in both directions between these two fields is super important. And one of Alison Gopnik's work is looking at a kind of task. It's called blicket detection, if you want to look that up, that even children can do that language models actually really struggle with. So by identifying these examples that are really easy for humans, but really hard for current AI, we can identify current technical limitations, which, if solved, can potentially have a big effect on AI capabilities.
Thank you. One comment by S. Gupta. He says, why do you say that models are learning only once and not continuously?
It's just the way they are trained today. So there are 2 or 3 phases. The big one is pre-training. So you get all the, I'm talking specifically about language models, of course. You get all the data from the internet and train a model. And now, companies are talking about something called mid-training. Let's ignore that for a second. And then there's a fine-tuning process to make them better at making conversation, avoiding undesirable outputs, improving the reasoning a little bit, that sort of stuff. And then you deploy them to users, and they're not really learning from every one of those interactions. What companies do is they take logs of those interactions and user feedback on those interactions, thumbs up, thumbs down, that sort of thing. Then they go through a big manual filtering step to take some subset of those and then put that into the next batch of fine-tuning data. That's a very slow and cumbersome process that takes, I would imagine probably weeks, given that there are many kinds of quality checks that need to be done, as opposed to the way in which humans learn continuously, which is, just kind of instantaneously. And to get LLMs to do that, again, I think we don't currently have good ways.
Thank you. This next question is from Shubham Kesharwani. He says, hi, Professor. What do you think about the talk of emergence phenomena in large models? The magic part. Yeah. Can you elaborate a little bit on what is meant by it?
Definitely. So emergent phenomena in language models are capabilities that you didn't specifically train for, but you find out that just by making a bigger model, it becomes really good at that task. And sometimes there can be a rather sudden increase in the ability to perform that task, whether it's language translation, question answering, you can imagine various tasks that chatbots are good at. And so these are called emergent phenomena. I don't really think there's any magic there. Like I was saying in my talk, the reason models are learning these things is because those things are represented in the training data, right? In the training data consisting of web pages, there are millions of examples of texts in multiple languages, and so the model is able to learn how to do that. It's not, it's not new mysterious abilities that are emerging out of nowhere. So there's usually a pretty direct connection between something in the data and the training abilities. Yes, it's very surprising that simply training models to predict the next word better is allowing them to acquire these emergent abilities. The general explanation for that is that if you're good at doing these tasks, right, to learn how to translate, or if you're good at playing chess, then it will be easier to predict the next move in a sequence of chess moves compared to if you know nothing about chess. So it essentially forces models to learn something about chess just in order to be better at predicting the next move in a sequence of chess moves. And yes, it is surprising, but it is nothing magical.
Great, thank you. This question is from Sanjeev Kumar. He says, Professor, what are the industries and use cases where AI will have or will add highest economic value in your perspective?
It's certainly hard to predict that, but I think one big one is tech itself. I think programmers are perhaps, simply in terms of the current amount of economic value that is being done with the help of AI. Programming is probably right now the biggest activity. Beyond that, Yeah, I mean, I would say, generally, I think any kind of knowledge worker can benefit from AI, and I think this still remains underappreciated. So I think, when I started playing with AI and experimenting with different ways in which I could use it, I discovered that there were just so many use cases. To give one example, language models, in my view, are not very good at writing. They generate this really boring kind of prose that's kind of an averaged out version of everything that they've seen online. So at first I thought, LLMs are not really good at helping me with my writing, but it turned out that they were really good for idea generation or giving it a piece of text and saying, do you think this is going to be understandable to someone who doesn't know much about AI? So anticipating the reaction of different kinds of readers. So with a bit of practice, I found that there were so many different ways to actually use AI assistance in my writing. Not the writing itself, but a lot of the activities that go into writing. So I think it's really on a case by case basis. Instead of me trying to predict which professions will see the biggest impact, we should, I think, just look at professionals in those fields who have experimented with AI and look at what they're saying instead of what AI experts are saying.
Great, thank you. Uh, this this one is from Shal Kumar. He says, "Is there any other way to advance AI beyond more data and more compute power?"
Sure. I mean, machine learning was not the only approach to AI, right? It's the most prominent one, and of course, large language models are a type of machine learning. But in the past, we used to have symbolic systems. Traditional chess playing AI was not machine learning. We used to have so-called expert systems, which are large databases of information. And many people are still working on the dream of, bringing back symbolic systems, bringing back so-called good old-fashioned AI, and at least combining deep learning with those more symbolic ways of reasoning. Yeah, and I think there's huge potential there, and I think there's a lot of people working on it.
Great, thank you. Mudit Kumar says, "Is it possible that over time we get to depend on AI so much that we lose our own capabilities to think and analyze?" The Dali scenario, I guess.
Yeah. That's definitely a danger. And, there are well-known examples of automation making certain human tasks harder. So pilots, for instance, can become inattentive when they're on autopilot and when they need to take over quickly. It can be challenging. Yeah, these are well-known phenomena. So it can happen either in the moment or over a long period of time. Some of our skills atrophy and we don't know how to do it ourselves. It is, of course, something that we've faced historically. I mean, if you go back, 60 years, people were worrying that if everybody is going to rely on compilers to write code and not doing their own assembly language programming or directly writing machine code, they're going to lose that knowledge. And there were concerns about that. I mean, we managed to do okay. Those are real risks, but I think uh, there's going to be a subset of people who make sure they know how to do those things like write machine code or assembly code and whatever other skills that AI is going to make obsolete. But not everybody will need to learn those skills. I think schools will need to figure out which skills have to be taught to children, even if they can be automated. So just because calculators can do multiplication, we haven't stopped teaching children arithmetic. That still remains important. But on the other hand, there are skills that we don't need to learn, like writing machine code. Most of us don't need to learn because that can be automated. So I think it's a critical role for educators to classify automatable tasks into essential ones that people still need to understand and things that is okay to rely on AI for. And a lot of my own challenge as an educator is in trying to make that distinction.
Thank you. We'll take maybe 3 or 4 more questions. This one is from Shal Kumar again. He says, "What's your take on using synthetic data for training AI models?"
Yeah, thanks. We addressed this in a lot of detail in one of our newsletter posts. It's called AI Scaling Myths, and we have a section on synthetic data. Let me give you a quick thought now. Synthetic data can certainly be very useful for certain things. So you can have synthetic data. Let's say you can have just to give a toy example, you can have AI play chess games against itself, and you can put that into the training data for an LLM, and that'll probably make it better at playing chess, right? It's going to help with chess, with writing code, and various kinds of more mathy kinds of areas. Synthetic data can help with generating higher quality training data. So many models like Microsoft Phi are using this approach, and there are even rumors that OpenAI is using this approach in creating these distilled models like GPT-4o Mini, which they announced just this last week. So it has certain roles, but I don't think we should expect that you can generate, petabytes of synthetic data and use that to train the next generation of bigger LLMs. I don't think that's going to happen. Synthetic data can help with certain specific skills. It can help with the quality of data. It's not going to help with the volume of data. That's our conclusion.
Thank you. This one is query by Dheeraj Shetty. He says, can you talk a little bit about your upcoming book, the title of which is AI Snake Oil? Will it be coming up in print, paperback, hardcover, in Amazon or to Amazon India? He only sees the Kindle version available for pre-order now.
Yeah, thanks. So I'm pretty sure it's available for pre-order in India in print. If somehow you're not seeing it, feel free to send me an email. I'll connect you to our publisher. Yeah, it's available for pre-order, I think pretty much everywhere, both in print and the Kindle version. Yeah, so we talk a lot about generative AI in our book, and a lot of the themes are going to be the same as what I talked about here. But a big thing that's in our book that I didn't talk about here is predictive AI. So this is AI that's used in hiring, in education, in banking, and so forth, trying to predict what a person will do in the future or how well they're going to perform a certain task. So there's so much hiring automation, as you might know, machine learning models that are looking at CVs and trying to predict, is this person going to be a good employee for my particular job? And HR departments are using this to screen employees. In education, it's being used to track kids into different groups. Banks are using it to determine loan decisions and so forth. And we're very, very critical of predictive AI. There's a lot of research showing that you just can't predict the future that well. And when it's used in highly consequential areas like criminal justice, where defendants are scored by an algorithm, and if they're considered to be high risk, then they're jailed before their trial, right? Jailed without a conviction. These are really major issues in terms of justice and fairness, and so we have to be really cautious about applying predictive AI. We also talk about the AI that's used on social media. We talk about how journalists often knowingly or unknowingly amplify AI hype. We talk about what we can all do as individuals, as consumers, to be more careful about AI hype and how we make our decisions about which AI products to use. We talk a little bit about AI policy. So broadly speaking, I think it's about the fundamental skills that will be helpful to you to look at all the news that's coming out in AI and to be able to make sense of it and to be able to separate hype from reality.
Great. Thank you. There are a lot of thank you notes. Great talk, Professor Narayanan. A lot of people congratulating you on such a wonderful, insightful talk. There's one last, not a question, but a comment or maybe your insight, request for your insight. This is by Gunjan Baglaji. He says, how can experts such as yourself get their insights into mainstream media where fear-mongering makes money and all that? What are your thoughts on how other opportunities may exist? Yeah.
Yeah, I wish I knew the answer to that. Certainly, a lot of fear-mongering about AI and other topics drives clicks. I do think that is a really big issue. But I think, experts in any area just have to do their best. So one thing we found is that instead of social media or even the mainstream media, writing a newsletter has turned out to be a really good way to get our insights out to people. There are a lot of journalists that subscribe to our newsletter, AI researchers, policymakers, various other kinds of people. And I think this is kind of a new development in the last 5 years. There was not a very strong newsletter ecosystem. And I've been pleasantly surprised to see that a lot of serious thinkers have started choosing newsletters over either social media or talking to journalists as a way of getting their evidence-based insights out there. So I find myself both subscribing to a lot more newsletters now on Substack and various other forums, as well as getting my own ideas out through the newsletter format as opposed to other formats.
Great. Thank you. I think this is all the time that we have today. I'm sorry, Manu, Goel, I couldn't take your question or comment fully. Vikash, Arvind, Ajay, and a few others. I apologize for that, but we must wrap up now. Thank you so much, Professor Narayanan, for such a wonderful talk. For all the attendees, as I mentioned in the chat as well earlier, recording of this presentation will be available. Please check out the PanIIT USA YouTube channel. Within a few days, it should be posted there. Thank you again, Professor Narayanan, and thank you everyone for joining today. See you
Thank you
next
so
time.
much. This was really fun.
Thank you.